Coffee begins as a small red cherry growing on plants that can live for more than a century. But inside that simple fruit hides a biochemical world so complex that more than 800 aromatic compounds are released when heat transforms the bean. Coffee was once eaten for energy, long before it became a drink. And even decaffeinated versions still carried traces of the stimulant that shaped human mornings everywhere. Espresso looks powerful, but actually contains less total caffeine than a regular mug of drip coffee, and yet this surprising imbalance plays a role in how the body reacts to different brewing methods. As modern research continues uncovering deeper layers of how caffeine molecules interact with metabolism, neurons, antioxidant pathways, mitochondrial function, and long-term health markers, coffee begins to look less like a casual beverage and more like a functional ally for those seeking a longer, healthier life. What follows is a journey through the science of coffee and longevity, how this ancient bean influences inflammation, metabolism, cellular resilience, brain health, liver function, and the subtle rhythms of human biology. Coffee interacts with the human body in ways that go far beyond alertness. Compounds inside the bean act on pathways related to oxidative stress, helping stabilize free radicals that naturally accumulate through daily metabolic processes. These same compounds influence energy metabolism and fat oxidation, contributing to studies linking coffee consumption with lower risks of metabolic disorders. When researchers explore long-lived populations, coffee often appears as a consistent part of daily routines, not because it is magical, but because it interacts with the body's own protective systems in measurable ways. This interaction is shaped not only by caffeine, but also by polyphenols, deuterpenes, trigonelline, chlorogenic acids, and other molecules that remain active through the roasting and brewing process. To keep listeners engaged, the early moments highlight one key idea. Coffee is not simply a stimulant. It is a complex botanical source of bioactive molecules that influence longevity-related systems. Many people think caffeine is the main reason coffee makes them feel energized, but caffeine is only one piece of a larger biochemical picture. Chlorogenic acids may help support glucose processing, while trigonelline and its roasted form contribute to metabolic flexibility. The drink also contains compounds that may influence the gut microbiome in ways that promote stability and resilience. Because the microbiome has been studied as a major player in immune function, mood regulation, and metabolic health, coffee's indirect support of microbial diversity becomes an important factor in discussions of long-term well-being. When examining brain health, researchers consistently find associations between regular coffee consumption and lower risks of cognitive decline. This is partly due to caffeine's ability to protect neurons from excessive adenosine signaling, helping maintain alertness and reaction time. But the long-term effects appear tied to polyphenols that support neuronal tissues. Studies also show improvements in memory performance, attention, and processing speed shortly after consumption. But more interesting are the findings suggesting a protective role for decades. Because coffee interacts with both the central nervous system and the bloodstream, it influences brain function through several pathways at once. A significant area of longevity research focuses on inflammation, which is often linked to aging. Coffee's compounds appear to modulate inflammatory markers in ways that may support healthier aging trajectories. For instance, chlorogenic acids have been shown to influence oxidative stress, helping neutralize molecules that would otherwise accumulate and contribute to cell damage. This effect becomes more relevant as metabolic demands increase with age. Coffee also appears to support vascular function, with studies showing improvements in endothelial responsiveness, which relates to blood flow. Good vascular health is consistently associated with longevity, particularly when linked to brain and heart function. Coffee consumption may also help support healthy blood sugar levels. Research indicates that both caffeinated and decaffeinated coffee are associated with improved glucose metabolism. This is notable because it suggests that many of coffee's benefits do not depend solely on caffeine. Diterpenes found in unfiltered coffee, such as cafestal and kawil, have been studied for their roles in metabolic support, though they can also influence cholesterol levels depending on the preparation method. Understanding these nuances allows a more accurate picture of how coffee interacts with individual health goals. Another area of interest is liver health. Multiple studies show strong associations between coffee consumption and reduced risk of liver-related conditions. This appears linked to coffee's influence on enzymes that regulate detoxification and inflammation. People who regularly drink coffee often show lower levels of enzymes associated with liver stress, suggesting a protective effect. The liver plays a central role in metabolic health, energy production, and hormonal regulation, making its stability essential for longevity. Coffee's role in physical performance is also relevant. Caffeine has been shown to increase the availability of fatty acids as a fuel source, improving endurance. This contributes to better exercise outcomes, which are strongly tied to long-term health and vitality. Enhanced performance supports muscle maintenance, cardiovascular fitness, and metabolic resilience, key markers that predict healthier aging. Coffee's influence on mood contributes indirectly to longevity because emotional stability affects sleep, stress response, and overall lifestyle. Moderate coffee consumption is associated with improved mood, lower risk of depressive symptoms, and increased motivation. These effects appear related not only to caffeine, but also to the drink's impact on neurotransmitter pathways. When discussing coffee and aging, it is helpful to consider how it interacts with cellular energy production. Mitochondria are often described as the powerhouses of cells, and coffee contains compounds that may help support mitochondrial efficiency. Better mitochondrial function translates into improved energy levels, metabolic stability, and resistance to cellular stress. Coffee can also influence autophagy, the body's natural process of cleaning out damaged cells. While fasting is known to enhance autophagy, some research suggests that coffee may stimulate similar pathways even without caloric restriction. This connection between coffee and cellular maintenance contributes to the growing interest in how the beverage might support long-term vitality. Another significant factor is DNA protection. Oxidative stress can damage DNA over time, influencing aging at its core. Antioxidants found in coffee may help protect cellular structures, contributing to long-term resilience. This protective effect is subtle and accumulates over years, aligning with the concept of slow, steady longevity support. Coffee interacts with metabolic hormones as well. Studies indicate that caffeine can influence hormones related to appetite and energy regulation, contributing to weight management. Maintaining a stable weight lowers risks associated with metabolic aging and chronic conditions. Coffee's role in digestive health is also notable. Its natural acids and compounds stimulate gastric movement, aiding digestion. Additionally, certain coffee compounds appear to feed beneficial gut bacteria, contributing to better microbial diversity. Coffee may even influence sleep in beneficial ways when timed appropriately. Although caffeine can disrupt rest if consumed too late, moderate intake earlier in the day can improve overall sleep quality by enhancing daytime alertness and regulating the circadian rhythm when used consistently. The drink also interacts with bone metabolism, though research shows that adequate mineral intake balances any potential concerns. When consumed responsibly with proper nutrition, coffee does not appear to harm bone density and may even be associated with neutral or slightly positive outcomes in some studies. Coffee's relationship with heart health is complex, but increasingly understood. While very high intake may not suit everyone, moderate consumption is consistently associated with lower risks of cardiovascular issues. This is tied to its effects on blood vessels, inflammation, and antioxidant status. Coffee's cultural role also contributes to well-being indirectly. The routine of preparing and drinking coffee creates moments of pause, reflection, and social connection. Factors linked to long-term mental health and life satisfaction. Coffee, as part of a longevity-focused lifestyle, becomes a combination of its biochemical effects and behavioral patterns. Drinking it mindfully, without adding excessive sugar or harmful additives, allows its natural compounds to be most effective. Coffee roasting levels also affect longevity-related benefits. Light roasts retain more antioxidants, while darker roasts contain unique compounds formed during roasting. Both provide distinct advantages, contributing to a diverse profile of bioactive molecules. Cold brew coffee presents another angle. Because it is brewed at lower temperatures, it contains different concentrations of acids and antioxidants, offering a smoother alternative for individuals sensitive to acidity. Even the method of grinding and storing coffee influences its freshness and antioxidant content. Freshly ground beans preserve more of their beneficial compounds, supporting the drink's potential advantages. Coffee's benefits accumulate over time. While a single cup may improve focus and energy, years of consistent moderation contribute to long-term health patterns. Coffee is a naturally low-calorie drink, making it compatible with longevity nutrition strategies focused on reducing metabolic load. Its ability to increase alertness also supports productivity and cognitive performance throughout the day. Coffee's role in fat oxidation has been well documented. This metabolic shift supports physical endurance and weight management, both important factors for longevity. Coffee interacts with neuromodulators, like dopamine and serotonin, contributing to enhanced motivation and emotional balance. These influences support overall well-being and indirectly contribute to healthy aging. Coffee's combination of caffeine and polyphenols supports balanced energy, rather than a sudden spike followed by a crash, when consumed without excessive sugar. This steady energy curve aligns with metabolic stability. Coffee's antioxidants may help support immune function by reducing oxidative pressure on immune cells. A more balanced immune response benefits overall health. Coffee influences platelet function and may support healthier blood flow when consumed in moderation. Good circulation contributes to better oxygen delivery throughout the body. Coffee's protective effects appear strongest when consumed black or with minimal additions. This keeps the focus on beneficial compounds rather than added sugars or artificial ingredients. Coffee provides a unique synergy between caffeine and antioxidants, making it distinct among beverages commonly consumed worldwide. Coffee contains magnesium, potassium, and other trace minerals that support essential biological processes, though these are present in modest amounts. When combined with a nutrient-rich diet, coffee becomes an additional supportive element of daily nutritional intake. Coffee may influence skin health through its antioxidant activity, supporting resilience against oxidative stress that contributes to visible aging. Coffee can help maintain cognitive sharpness by supporting neurotransmitter balance and brain circulation, which collectively benefit long-term mental performance. Coffee preparation traditions around the world reflect diverse brewing methods that extract unique profiles of compounds, each with slightly different impacts on health markers. Coffee pairs naturally with periods of focused work or study, supporting productivity, a factor associated with mental well-being and fulfillment across life. Coffee consumption is associated with reduced risks of several age-related metabolic challenges, reflecting its wide-reaching biological influence. Coffee continues influencing the body long after the last sip. The metabolic rise that follows caffeine intake increases thermogenesis, which is the body's natural heat production process linked to energy expenditure. This contributes to studies showing that people who regularly consume coffee may burn slightly more calories at rest, a factor that becomes more relevant with age when metabolic rate tends to slow. Although the effect is modest, its consistency over years forms part of coffee's connection with long-term metabolic stability. Another important area of longevity research involves how coffee affects adiponectin and other metabolic hormones that regulate fat storage and insulin sensitivity. Higher levels of adiponectin are associated with better metabolic health and lower inflammation. Studies suggest that coffee consumption may support these hormonal patterns, making it valuable for maintaining balanced metabolic function over decades. People who drink coffee regularly often show improved markers of insulin sensitivity, which is a key component of preventive strategies for age-related metabolic conditions. Coffee's impact on cardiovascular longevity becomes clearer when analyzing large population studies. Moderate consumption has been consistently associated with lower mortality rates from cardiovascular causes. This is partly due to coffee's influence on endothelial function, which describes how effectively blood vessels relax and contract. Good endothelial function is important for maintaining stable blood pressure and healthy circulation. Coffee's antioxidants, in particular chlorogenic acids, help reduce oxidative stress within blood vessels, supporting their long-term resilience. Another compelling aspect of coffee's longevity profile involves its effect on telomeres. Telomeres are protective caps at the ends of chromosomes that gradually shorten as cells divide. Shorter telomeres are associated with faster aging. Some research suggests that coffee drinkers may have slightly longer telomeres or slower rates of shortening, potentially due to reduced oxidative stress and inflammation. While the effect is gradual, its presence reinforces coffee's role in cellular maintenance. Coffee's influence on the gut highlights another longevity-related mechanism. The gut microbiome plays a major role in immune function, nutrient absorption, mood regulation, and metabolic control. Compounds in coffee appear to stimulate the growth of beneficial bacteria, contributing to improved microbial diversity. A healthier microbiome supports lower inflammation and better metabolic flexibility, both of which are fundamental pillars of longevity science. Coffee drinkers often show increased levels of short-chain fatty acids and other metabolites associated with gut health. Coffee's role in liver protection continues to be one of the most consistent findings across scientific literature. People who drink coffee regularly show lower rates of liver enzyme elevations and reduced risk of liver-related diseases. This appears tied to coffee's ability to support anti-inflammatory pathways, influence detoxification enzymes, and reduce oxidative stress in liver tissues. The liver's central role in hormone balance, metabolism, and nutrient processing makes its protection a critical component of any longevity strategy. Another angle to consider is caffeine's ability to increase circulating levels of brain-derived neurotrophic factor, commonly known as BDNF. BDNF supports the growth and maintenance of neurons, helps form new neural connections, and supports brain plasticity. Higher BDNF levels are associated with healthier aging of the brain. Coffee's influence on BDNF may contribute to long-term cognitive resilience and may help explain why coffee drinkers show reduced risks of neurodegenerative decline. Coffee also interacts with adenosine receptors in the brain. Adenosine builds up during wakefulness and creates the feeling of fatigue. Caffeine temporarily blocks adenosine, increasing alertness and mental clarity. When done in moderation and timed earlier in the day, this interaction supports better daytime performance and may indirectly improve sleep structure by aligning wakefulness and rest cycles more effectively. Better sleep quality contributes to improved recovery, hormonal balance, and immune function, important factors for longevity. The type of coffee bean also influences the drink's health profile. Arabica beans tend to contain more antioxidants and lower caffeine levels, making them gentler for some individuals. Robusta beans contain more caffeine and certain antioxidants, offering stronger stimulant effects. Both varieties have unique chemical profiles that contribute to longevity differently, and blending them creates additional variations in antioxidant content and flavor while maintaining key beneficial compounds. Brewing method changes the concentration of longevity-related molecules. Filtered coffee removes most diterpenes like cafestol and cahoil, which can raise cholesterol in some individuals. However, these same diterpenes also offer anti-inflammatory and antioxidant properties when consumed in small amounts. Unfiltered coffee, such as French press or boiled coffee, retains these compounds. Understanding these differences allows people to choose brewing methods that align with their personal health goals. The temperature of brewing influences extraction. Hot water extracts antioxidants and caffeine efficiently, while cold brewing reduces acidity and alters the balance of bioactive compounds. Cold brew tends to be smoother and easier on the stomach, while still delivering a meaningful dose of antioxidants and caffeine. These variations show how coffee is not a fixed substance, but a dynamic beverage whose benefits shift subtly depending on preparation. Coffee's influence on physical endurance becomes especially relevant for longevity because maintaining physical capability is one of the strongest predictors of long-term health. Caffeine increases adrenaline release, allowing muscles to recruit more energy during physical activity. It also spares glycogen by increasing fat utilization, which delays fatigue. This combination helps people stay active longer, contributing to healthier aging. Coffee also appears to influence nitric oxide availability, supporting blood vessel dilation and improving nutrient delivery to muscles and organs. Healthy blood flow is essential for sustained vitality, cognitive clarity, and metabolic efficiency. People who consume coffee before exercise often experience improved performance and better oxygen utilization. Another promising line of research explores coffee's role in reducing advanced glycation end products, also known as AGEs. These harmful compounds accumulate in tissues as part of the aging process and contribute to stiffness, reduced elasticity, and inflammation. Some components of coffee appear to inhibit the formation of AGEs, supporting long-term tissue health. Coffee may also provide protective effects against age-related muscle loss, known as sarcopenia. By supporting physical performance, energy levels, and metabolic activity, coffee indirectly contributes to maintaining muscle mass, which becomes increasingly important with age. Muscle preservation is closely tied to mobility, strength, and overall quality of life. The brain benefits of coffee extend beyond alertness. Coffee supports faster reaction time, improved memory consolidation, and enhanced learning capacity. These effects may contribute to better cognitive performance over the long term, supporting independence and mental sharpness throughout aging. Coffee's antioxidant profile continues influencing systems, even when caffeine is removed. Decaffeinated coffee retains polyphenols and chlorogenic acids, meaning many longevity benefits remain available without the stimulant effect. This is important for individuals who prefer to limit caffeine intake but still want to support metabolic and cellular health. Coffee appears to support respiratory function as well. Caffeine can relax smooth muscles in the airways, contributing to better airflow. This is relevant for people with exercise-induced breathing difficulty and supports overall endurance. Coffee's role in hydrating the body is sometimes misunderstood. While caffeine has a mild diuretic effect, regular drinkers develop tolerance, and the fluid from coffee contributes meaningfully to daily hydration. Proper hydration supports metabolic processes and cellular health. Coffee interacts with the immune system through both direct and indirect pathways. Antioxidants reduce oxidative load on immune cells, and improved gut microbiome diversity strengthens immune resilience. A stable immune system reduces the impact of everyday stressors that accumulate during aging. Coffee provides support during fasting periods because caffeine can reduce appetite, improve mood, and enhance mental focus. Because fasting has longevity-related benefits through autophagy and metabolic adjustments, coffee can become a complementary tool within fasting-compatible lifestyle strategies. Coffee's impact on cholesterol depends on the brewing method, as mentioned earlier. But studies consistently show that moderate consumption of filtered coffee does not negatively impact cholesterol and may offer cardiovascular protection. Coffee's ability to improve alertness supports safer driving, better decision-making, and improved work performance. These benefits seem small, but contribute to long-term lifestyle stability and reduced risk of accidents or stress-related mistakes. The social dimension of coffee also plays a role in longevity. Shared routines, morning rituals, and small daily pleasures support mental health and emotional resilience, which influence long-term well-being. Coffee's impact on oxidative stress continues throughout the day. Its antioxidants circulate in the bloodstream, reducing cellular damage and supporting recovery from daily metabolic activities. Coffee supports metabolic waste clearance through improved circulation and liver function, helping maintain a clean internal environment for cells. Coffee contributes to nutrient absorption, particularly of antioxidants consumed with food. This synergy between coffee and meals may improve overall nutrient utilization. Coffee's relationship with longevity becomes clearer when examining how it interacts with metabolic stress. As people age, their cells encounter increasing oxidative pressure, and the efficiency of internal repair mechanisms gradually declines. The polyphenols in coffee help reduce this metabolic strain by neutralizing free radicals before they cause significant cellular damage. Over decades, this consistent reduction of oxidative stress supports healthier tissues and more stable organ function. Even small improvements in oxidative balance, when sustained, contribute to long-term resilience. Coffee also supports the body's ability to regulate inflammation. Chronic low-grade inflammation is considered one of the main drivers of aging because it contributes to tissue degradation, metabolic issues, and reduced organ function. Studies suggest that regular coffee intake is associated with lower levels of inflammatory markers. This effect appears linked to both caffeine and non-caffeine compounds, indicating that coffee's anti-inflammatory influence is a combined result of multiple bioactive molecules working through different pathways. In addition to its systemic effects, coffee influences metabolic flexibility, which refers to the body's ability to switch between using fats and carbohydrates for fuel. Good metabolic flexibility is a predictor of healthier aging because it helps maintain stable energy levels and reduces metabolic strain. Coffee enhances this flexibility by increasing fat oxidation, particularly during periods of movement or light exercise. This contributes to better weight stability and energy balance as people age. Coffee also affects calcium balance and bone turnover in ways that have been clarified in recent research. Early beliefs suggested that coffee might harm bone health, but modern studies indicate that when calcium intake is sufficient, coffee does not negatively affect bone density. In many cases, coffee drinkers who maintain adequate nutrition show no increased risk of bone loss, and some data even suggest neutral to slightly positive outcomes, highlighting the importance of considering full dietary context rather than isolating one beverage. Another longevity-supporting property of coffee involves its effect on the cardiovascular system's adaptability. With age, blood vessels tend to stiffen, making it more difficult for the body to regulate blood pressure. The antioxidants in coffee support vascular elasticity by reducing oxidative damage to the lining of blood vessels. Improved vascular flexibility helps maintain stable circulation, which benefits the heart, brain, muscles, and all organs that depend on efficient delivery of oxygen and nutrients. Coffee consumption is also linked to improved mitochondrial activity. Mitochondria generate the energy required for cells to function, and mitochondrial decline is considered a hallmark of aging. Some compounds in coffee appear to support mitochondrial efficiency and help cells use energy more effectively. Healthy mitochondrial function contributes to better endurance, sharper cognition, and improved metabolic control, all of which are important components of longevity. Another area of interest is how coffee influences detoxification pathways in the liver. The liver contains enzymes that process toxins, hormones, and metabolic byproducts. Coffee appears to support these enzymes' activity, helping the body maintain cleaner internal chemistry. When detoxification pathways function smoothly, the body experiences less metabolic burden, which helps preserve cellular health over time. This contributes to the consistent association between coffee consumption and improved liver markers in epidemiological studies. Coffee supports cognitive longevity through multiple mechanisms beyond BDNF. Caffeine's role in enhancing neurotransmission improves communication between brain cells, while polyphenols help protect brain tissue from oxidative stress. These combined effects contribute to reduced cognitive decline in long-term observational studies. People who regularly drink coffee tend to maintain sharper memory, better attention, and more stable mental performance as they age. Coffee's impact on mental health plays a major role in long-term quality of life. Moderate caffeine consumption is associated with improved mood and reduced symptoms of low mood. Because emotional stability influences lifestyle choices, sleep patterns, motivation, and social engagement. Maintaining positive mood through natural stimulants like coffee supports behaviors that promote healthy aging. Coffee's influence on dopamine and serotonin pathways helps explain these mood benefits. Another longevity-related aspect of coffee involves its role in maintaining digestive motility. As people age, digestion often slows, leading to discomfort and reduced nutrient absorption. Coffee stimulates gastric activity, helping the digestive system move more efficiently. This supports nutrient availability and digestive comfort, both important components of long-term health. Because digestion influences energy levels and microbial balance, coffee's contribution in this area adds another subtle but meaningful layer to its longevity profile. Coffee also influences calorie intake by reducing appetite temporarily. While not a weight loss solution on its own, this effect can help people avoid unnecessary snacking, contributing to healthier energy balance throughout the day. Maintaining a stable weight is strongly linked to longevity, as excess weight strains the heart, joints, and metabolic systems. Another notable benefit involves how coffee interacts with the sympathetic nervous system. Caffeine mildly stimulates the system responsible for alertness and readiness, which improves focus and reaction times. These improvements contribute to safer decision-making and reduced risk of accidents, especially in older adults. Maintaining mental sharpness and physical responsiveness supports independence and functional capacity across the lifespan. Coffee contains small amounts of minerals like magnesium and potassium. While not major contributors compared to whole foods, these minerals assist with nerve function, muscle contraction, and electrolyte balance. Even modest intake matters when consumed consistently over many years. Combined with a balanced diet, coffee's mineral content supports daily physiological stability. Coffee also plays a role in supporting skin health. Oxidative stress accelerates skin aging, contributing to wrinkles and loss of elasticity. Antioxidants in coffee help reduce this stress, supporting more resilient skin at the cellular level. Although coffee is not a cosmetic solution, its internal protective effects contribute to slower visible aging patterns in some individuals. Coffee influences the stability of blood sugar after meals. Polyphenols may help reduce the rise in glucose that follows carbohydrate intake by improving insulin sensitivity. When blood sugar remains stable, metabolic stress is reduced, and long-term health outcomes improve. This effect is relevant for individuals seeking to maintain healthy glucose patterns as they age. Another factor related to longevity is coffee's role in protecting DNA from oxidative stress. While all cells experience damage over time, regular intake of antioxidants helps maintain DNA stability. This reduces the likelihood of errors during cell replication and supports healthier tissues. Protecting DNA is central to slowing the biological aging process. Coffee's interaction with the gut-liver axis reflects another dimension of its effects. The gut microbiome influences liver health, and the liver influences metabolic stability. Coffee supports both systems simultaneously, creating a reinforcing cycle of metabolic strength and reduced inflammation. This interconnected support contributes to long-term vitality. Coffee also encourages individuals to maintain routines, which supports mental clarity and emotional stability. Daily routines reduce decision fatigue, support discipline, and create small psychological anchors throughout the day. Stability in everyday habits promotes consistent health practices, indirectly contributing to longevity. Coffee's influence on hydration may be underestimated. While caffeine has a mild diuretic effect in people unaccustomed to it, regular drinkers experience little to no diuretic response. The fluid provided by a cup of coffee contributes meaningfully to daily hydration needs, supporting cellular function, nutrient transport, and temperature regulation. Coffee contributes to cardiovascular endurance by supporting heart rate variability when consumed in moderation. Good heart rate variability is associated with healthier stress response and improved autonomic balance. This pattern supports longevity by helping the body adapt more easily to physical and emotional challenges. Coffee supports antioxidant recycling in the body. Some antioxidants become more effective when paired with others, and coffee's unique blend of compounds enhances this synergy. This means its protective effect extends beyond what any single molecule could provide. Coffee's connection to reduced mortality in large population studies reflects all these combined effects. While coffee itself is not a cure for aging, its influence on metabolism, inflammation, brain health, liver function, cardiovascular health, and cellular integrity creates a measurable pattern of improved long-term outcomes. Coffee continues to reveal new longevity pathways as research evolves. Its ability to influence metabolic pathways at the cellular level becomes clearer when examining how it interacts with AMP-activated protein kinase, commonly known as AMPK. This enzyme helps regulate energy balance, encourages the body to burn stored fuel, and supports cellular repair processes. Coffee appears to stimulate AMPK activity, contributing to improved metabolic efficiency and healthier energy utilization as people age. When AMPK functions well, the body maintains stronger resistance to metabolic stress, which is a key factor in longevity science. Another important mechanism involves how coffee affects oxidative enzymes in the bloodstream. These enzymes help neutralize reactive oxygen species before they damage tissues. Coffee's polyphenols appear to support this enzymatic activity, creating a more favorable internal environment for cells. Over many years, this steady support for antioxidant defenses contributes to reduced tissue wear and better overall resilience. Coffee's effects on cardiovascular longevity extend into rhythm stability. Moderate caffeine intake supports more consistent heart function during waking hours by enhancing alertness and reducing premature fatigue. Stable cardiovascular patterns support long-term vitality and reduce the risk of age-related decline in functional capacity. While individual responses vary, the overall pattern of research shows clear associations between moderate coffee intake and reduced cardiovascular mortality. Coffee's influence on endothelial nitric oxide synthase, an enzyme responsible for producing nitric oxide, helps support blood vessel dilation. Nitric oxide improves circulation, enhances oxygen delivery, and supports metabolic efficiency. When this system functions effectively, tissues receive more consistent nutrient and oxygen supply, contributing to better performance and healthier aging. Enhanced nitric oxide availability is one of the reasons coffee drinkers often experience improved exercise output. Another longevity-related effect arises from coffee's impact on metabolic rhythm. The body operates on internal cycles that regulate energy, digestion, hormonal release, and sleep-wake patterns. Coffee, when consumed earlier in the day, helps reinforce daytime alertness and supports stronger circadian alignment. Stable circadian rhythms contribute to healthier hormone regulation, improved metabolic outcomes, and better sleep quality, all of which influence aging trajectories. Coffee also supports mental clarity by increasing blood flow to the brain and enhancing synaptic activity. Faster neural processing and improved cognitive flexibility help maintain independence and functional capability later in life. Over decades, these small but continuous advantages accumulate into a measurable cognitive benefit. Regular coffee drinkers often display stronger memory performance and lower rates of age-related cognitive decline. Another compelling area of research explores how coffee consumption may reduce the risk of certain age-related diseases that impact health span. Many of these associations are linked to coffee's anti-inflammatory and antioxidant capacity and its influence on metabolic regulation. While coffee does not replace medical care or healthy lifestyle habits, its biochemical footprint aligns with mechanisms known to support longer, healthier living. Coffee contributes to muscle preservation by improving exercise performance and enhancing the body's ability to mobilize energy. Strong muscles support metabolic health, joint stability, and independence, making them essential for aging well. Even a small improvement in physical capability, supported by caffeine's effects on endurance, can influence long-term outcomes. The liver continues to stand out as one of the organs most consistently supported by regular coffee consumption. The reduction in liver enzyme markers observed in coffee drinkers reflects healthier liver tissue and improved detoxification performance. Because the liver regulates cholesterol, glucose, hormones, and nutrient distribution, its stability protects multiple systems simultaneously. Coffee's impact on the microbiome continues beyond initial digestion. Some compounds reach the large intestine, where they interact with microbial populations in ways that encourage diversity and beneficial metabolic output. A balanced microbiome contributes to better immune response, reduced inflammation, improved nutrient absorption, and more stable mood regulation. Each of these factors supports long-term health. Coffee also appears to support metabolic adaptability during periods of low caloric intake. People who incorporate fasting into their routines often find that coffee helps maintain alertness and energy without disrupting metabolic benefits. This compatibility makes coffee a supportive tool for those exploring longevity-focused dietary strategies. Another area where coffee supports longevity is through its influence on mental engagement. Improved focus and sustained alertness encourage individuals to remain intellectually active. Mental stimulation supports cognitive pathways that keep the brain strong, and long-term intellectual engagement is associated with healthier aging outcomes. Coffee, by enhancing cognitive readiness, indirectly supports this pattern. Coffee's detoxification benefits extend to its high antioxidant content, which helps the body neutralize environmental pollutants and metabolic byproducts. Over decades, lower oxidative pressure supports healthier tissues and more efficient repair mechanisms. This helps explain why coffee consumption is repeatedly associated with reductions in all-cause mortality across large populations. Coffee also appears to support better mobility by reducing perceived effort during movement. When physical activity feels easier, people are more likely to remain active. Regular movement supports cardiovascular strength, muscle preservation, joint health, and metabolic stability, all essential components of longevity. Even small improvements in perceived exertion contribute to better adherence to physical activity routines. Coffee's influence on lipid metabolism is another relevant factor. While unfiltered coffee can increase certain cholesterol markers, filtered coffee avoids this issue and often contributes to improved lipid profiles. Many population studies show lower cardiovascular risk among moderate coffee drinkers, further supporting its role in healthy aging. Coffee's antioxidants help protect skin cells from oxidative stress, contributing to a more stable skin structure over time. While this effect is subtle, it reflects the broader pattern of internal protection that supports healthier aging both inside and out. Coffee also influences appetite regulation, which plays a role in maintaining a healthy body weight. Stable weight lowers metabolic strain and reduces long-term risk of chronic conditions. When combined with balanced nutrition, coffee supports a healthier energy pattern throughout the day. Coffee's combination of caffeine and polyphenols creates a unique synergy that supports alertness without overwhelming the nervous system when consumed responsibly. This steady stimulation helps maintain productivity, motivation, and cognitive sharpness, contributing to emotional and psychological well-being. Coffee aligns with many modern longevity strategies by supporting metabolic health, reducing oxidative stress, enhancing cognitive performance, improving vascular function, and stabilizing liver chemistry. Its broad range of effects reflects the complexity of the human body and the interconnectedness of its systems. Coffee's benefits become clearer when evaluated across decades rather than days. While each cup produces immediate effects, greater alertness, improved focus, better mood, the long-term impact is rooted in consistent support for essential biological processes. People who incorporate moderate coffee consumption into a healthy lifestyle often show patterns of improved metabolic resilience, stronger cognitive function, and reduced markers of biological stress. Coffee remains one of the most researched beverages in the world, and its relationship with longevity continues to be supported by emerging evidence. Its combination of antioxidants, bioactive compounds, and metabolic effects forms a unique profile that aligns with key determinants of long-term health. When consumed mindfully and without excessive additives, coffee becomes a meaningful ally in supporting a longer and healthier life.